Algebra 1, Lesson 72, factors that are sums, and then pyramids and cones. So factors that are sums continues our exploration into trinomials. And what they mean by factors that are sums is a greatest common factor. Hidden inside of this expression is the trinomial, I'll go ahead and underline it, x squared minus x minus 6. Right? So we see that x2, x1, x none. However, next to every single one of these terms, we have this annoying greatest common factor that is actually a sum, or a polynomial. And that's seen in a plus b, and a plus b. So guess what our greatest common factor is going to be? Yep, a plus b. So we write a plus b off to the side, and then we'll separate our trinomial. So then we have x squared minus x, don't forget about that sign, and then minus 6. So once we identify our greatest common factor and we pull it out, this is a lot easier to look at, and then we can know exactly what to do from here. We can start solving using our trinomial factoring. So again, don't forget to write your greatest common factor out in front, and then we put our two sets of parentheses and we use our trinomial factoring. So x squared becomes x and x. Last sign is negative, so we have a positive and a negative. And then factors of 6 are 1 and 6, and then 2 and 3. The numbers that are -1 apart are 2 and 3. Since the negative wins, 3 will be, the bigger number will go to the negative. So 3 and 2, and that is my answer. A plus b parentheses, x plus 2 parentheses, x minus 3 parentheses. So that's factors that are sums. Now, that didn't take very long, and that's because we have to spend quite a bit of time talking about pyramids and cones. Specifically, how to find the volume of pyramids and cones, and then how to find the surface area of pyramids and cones. So, remember, if you remember a little while back, I taught you guys that the overall equation for volume is area of the base times the height, right? That equals volume of everything. Almost. Right? So now let's talk about the volume of a cone and a pyramid. So the funny thing about volume of pyramids and cones, that's these pyramids, cones, is that their volume is exactly 1/3 times this. So, and then we can go ahead and change that to cone. So the volume of a pyramid or a cone is 1/3 times the area of the base times the height. And that equals volume of cones and pyramids. So the area, or the base of a cone, is going to be a circle. The base of a pyramid is going to be a rectangle, or sometimes it could even be a triangle if we have a triangular pyramid. But it will always be 1/3. So let's do a practical example. We'll find the volume of this right rectangular pyramid. So the base, we have a rectangle that is 9 and 7. So the base is going to be 9 times 7, which is 63. 63 times the height of 8. So we'll plug this in. Area of the base is, as we just found out, 63. The height is 8, and then all of that is being multiplied by 1/3. Now, the reason why I did it like this is because I can cross cancel this 3 and this 63. I could multiply 63 times 8 and then divide all of that by 3. Or, since I like to take shortcuts, I could divide 63 by 3 right now. And that gives me 21. So now all I have to do is multiply 21 times 8. 8 times 20 is 160 times 8, 168. So the volume is 168 units cubed. So volume, not so bad. Now, what if we're doing the volume of a cone with a circular base? So let's try this one. We have a radius of 6 on the base and then a height of 6. So in this case, the area of our base is going to be pi r squared. And then we saw that our radius is equal to 6 and our height is equal to 8. Sorry, this is a little jumbled. So what we're going to do is we are going to have 1/3 times pi r squared, the area of our base, times our height. So when we plug this in, what we actually have is 1/3 times pi r squared is going to be 36, 6 times 6, 36, times our height of 8. And then again, what I'm going to do is I'm going to try to cancel that 3. So 3 goes into 36 12 times, So pi times 12 times 8. 12 times 8 is 96. I almost said 108, that's 9. So 12 times 8 is 96. So what we have is 96 pi units cubed for our volume. Or we could go ahead and multiply 96 by 3.14 and get a decimal answer. So that's a volume of cones and pyramids. Not too difficult. Area of the base times the height. All we're doing now is we're multiplying by 1/3, or you could also say dividing by 3. Now surface area gets a little bit tricky, especially when we're doing lateral surface area, because on pyramids we have 1, 2, 3, 4, 5 different spaces. We have the area of the base, and then the lateral surface area is the 4 triangular sides. On a pyramid, what's great is that all 4 of these triangles are equal, exactly the same. They have a base of 6 and a height of 5. And we see that down here. So we take the area for a triangle, which is 1/2 base times height. So they take 5 times 6, which is 30, divided by 2, they get 15. They get 15 for each side of those triangles. 15 times 4 gives them, here, let's go ahead and do this here. So if I take the lateral surface area of this pyramid, I've got 1, 2, 3, 4 triangular walls, and then 1 square base. So these are all 5 surfaces of this pyramid right here. Right? Now if we look at all of these surfaces, they all have a height of 5, or all these triangles have a height of 5. They all have a base of 6. And this bottom is actually a square of length 6 and 6. I know it looks more like a rectangle. That's just because I'm not a great drawer. So for lateral surface area, all I care about is these 4 walls. If I want to find total surface area, then I add the area of the base as well. So let's find the area of one of these pyramid, or one of these walls of the pyramid, or one of these triangles. So I take the base times the height, which is 5 times 6, and then I divide it by 2. So that gives me 30 divided by 2, which equals 15. So if one triangle is equal to 15 units squared, then all 4 triangles is equal to 15 times 4. So I could add 15 4 times, or I could just take 15 times 4, and then I get 60. So 60 units squared, that equals the lateral surface area. And then if I want to find the total surface area, all I do is I add the area of the base. So 6 times 6, 36. 60 plus 36 is 96 units squared. That equals total surface area. Now, the last one, surface area of the dreaded cone. I don't know why I decided to draw this. Their drawing is better than mine. So we have a cone. And I'm trying to draw this guy right here, or that guy. Right circular cone. I want to find the lateral surface area. So the easiest way to do this is to memorize the equation. Lateral surface area of a cone is pi times radius times the slant height, which they represent with lowercase l. Now, what is the slant height? It is the distance from the tip of the cone to the side of the base. Slant height. So, in the example that they give us, our cone has a radius of 8 and a vertical height of 10. Oh no, I'm sorry, a slant height of 10. So, slant height is 10, radius is 8. So all I have to do is take pi times 8 times 10, which means that the surface area is 80 pi units squared. All right, cool. That was pretty simple. Or sorry, that's the lateral surface area. Now, if I want to add the area of the base, I have to find the area of the circle. So the area of the circle is going to be pi r squared, or 64 pi units squared. So then I would just add that, and that would give me 144 units squared. So this is lateral surface area up here, and then that equals total surface area. So then that's the surface area of a cone. So for surface area of a cone, don't forget to memorize this equation for finding the lateral surface area. And then if you need the area of the base. Don't forget area of a circle. Okay, if you have any questions, let me know on Moodle, and I will see you in class.